Check.
Check, check, check. Check, check.
Table में क्या चाहिए लैपटॉप yes report देना चेक कर रहा हूँ
I request the audience to please rise as the dignitaries have arrived. I kindly request the dignitaries to please take the stage. Thank you. Please be seated. A very good morning, ladies and gentlemen. A warm, gracious welcome to one and all to this inaugural ceremony of NMITCON 2025, hosted by Nitte Meenakshi Institute of Technology at Nitte University Campus, Bengaluru, in collaboration with the IEEE Bangalore section and with the academic partnerships from the University of Technology, Mauritius, and the University of Salamanca, Spain. Nitte Meenakshi Institute of Technology, popularly called NMIT Bangalore, established in 2001 and recognized by the All India Council for Technical Education, New Delhi, is now a constituent college of Nitte deemed to be University, Bangalore, since October 2024. NMIT is ranked within the rank band of 101 to 150 in the National Institutional Ranking Framework, NIRF 2024, by the Ministry of Education, Government of India. Also, NMIT is accredited with the NBA Tier 1 and accorded with A+ grade by NAC and Platinum grade by AICTE CII Survey of Industry-Linked Technical Institution of 2020. NMIT, the off-campus center of Nitte deemed to be university, is located at Yelahanka, Bangalore.
We are honored by the presence of our esteemed dignitaries, celebrated researchers, and enthusiastic scholars who have come together to celebrate innovation, technology, and celebration. To officially begin this event, I now invite Dr. Soumya Madhavan, Associate Professor and Head, Department of Electrical Engineering, VLSI Design and Technology, to come deliver the welcome address.
Good morning, all. Respected dignitaries on the dais, off the dais, heads of the departments, my dear colleagues and participants, a very good morning to one and all present here again. I feel delighted to welcome the gathering for the inauguration of the third International Conference on Networks, Multimedia and Information Technology, organized by Nitte Meenakshi Institute of Technology, Bangalore, in association with IEEE Bangalore section. I feel privileged to welcome our today's chief guest, Professor Dr. Joan Manuel Corchado, Rector, University of Salamanca, Spain. He is currently serving as a rector and professor at the University of Salamanca. He is a director of the Bioinformatics, Intelligent Systems and Education Technology Research Group, where he leads pioneering research in emerging technologies. He also holds visiting professorships at the Osaka Institute of Technology, Japan, and University Malaysia, Kelantan. Professor Corchado has held several prominent leadership positions, including Vice Rector for Research at the University of Salamanca and Director of its Science Park. He has served 2 terms as Dean of the Faculty of Science and has been the President of the IEEE Systems, Man and Cybernetics Society. Professor Corchado has spearheaded numerous postgraduate programs at the University of Salamanca, including master's degree in several areas such as smart cities and intelligent buildings, blockchain, cybersecurity, digital animation, etc. He also serves as the editor-in-chief of the journal titled Advances in Distributed Computing and Artificial Intelligence. His research interests span a wide range of domains such as artificial intelligence, machine learning, fintech, blockchain, cybersecurity, and many more. It's my pleasure to welcome you, sir. May I now request the Administrator, Shri Rohit Punja sir, and Principal Dr. H.C. Nagaraj sir to welcome the Chief Guest.
Sir.
Salokya. Okay, ready? Send.
Indeed, it's a grateful occasion to extend the heartiest welcome to our guest of honor, Professor Dr. Supavati Aramvith, Chair IEEE Thailand Section and Head Multimedia Analytics and Processing Research Unit, Department of Electrical Engineering, Chulalongkorn University, Thailand. Professor Supavati Aramvith is a renowned academic and researcher in the field of video technology. She earned her BS degree with first-class honors in computer science from Mahidol University and went on to receive her MS and PhD in electrical engineering from the University of Washington, USA. In Chulalongkorn University, she served as a professor in the electrical engineering department where she specializes in video technology. With a strong With a strong commitment to academic excellence, Professor Aramvit has successfully guided 14 PhDs, 36 masters, and 47 bachelor students, and has published over 150 research papers in international conferences and journals, along with 4 international book chapters. She currently holds several prestigious leadership roles, to name some of them: Chair IEEE Thailand Section, Chair-elect IEEE New Initiatives Committee, Treasurer IEEE Product Safety Engineering Society, and several more. Professor Supavati Aram, with exceptional blend of academic, technical, and organizational leadership, continues to make a significant impact in both Thailand and across the global engineering community. It's my pleasure to welcome you, Madam. May I now request Dr. Manjula BM, Professor and Deputy HOD, Department of EMC, to welcome the guest of honor.
Madam, look here. Sir, look here. Okay, ready? Okay.
It's indeed a pleasure to warmly welcome ever-inspiring Shri Rohit Punja Sir, Administrator of Nitte Education Trust, to this program. I am pleased to welcome you, sir. I extend my warm welcome to Professor Sandeep Shastri, Vice President, Nitte deemed to be University, in his absentia. I would like to extend the warmest welcome to Dr. H.C. Nagaraj, Principal, Nitte Meenakshi Institute of Technology. I am pleased to welcome you. I wish to extend my sincere welcome to Dr. Sudhir Reddy, Director, Curriculum Development, Nitte University Campus, Bengaluru. It's my pleasure to welcome you, sir. Also, I extend my cordial welcome to Dr. Kiran Aitar, Director, Research Development and Accreditation, Nitte University Campus, Bengaluru. Welcome you, sir. I wish to extend my warm welcome to Dr. Parmeshachari BD, Professor and Head, Department of Electronics and Communication Engineering, Nitte Meenakshi Institute of Technology. It's my pleasure to welcome you, sir. I would like to extend my warm welcome to all the plenary speakers and session chairs who have accepted our invitation and to be a part of this international conference. Also, my warm welcome to all the deans, heads of the departments, teaching and non-teaching staff members of all the departments of NMIT. I wish to extend my grateful welcome to all the coordinators of various committees of NMITCON 2025. Also, my warm welcome to all my dear participants of this conference who have come from various parts of the country. I appreciate and extend my gratitude for your excellent contribution and keen participation in this conference. Once again, I welcome you all for the NMITCON 2025 organized by NMIT Bangalore. Have a great day. Thank you, one and all.
Thank you, ma'am. On behalf of the organizing committee, we welcome you, ma'am. So let us now invoke divine blessings through a soulful invocation. I now invite Miss Nayanika to lead us in the invocation song. I request the audience to please rise.
Check.
Kiran sir. Kiran sir.
ಪಾಲಿಸು, ಈ ಬಾಳನು ಬೆಳಕಾಗಿಸು, ನಾಳೆಗಳ ದಾರಿಯಲಿ ನಂಬಿಕೆಯ ನೆಲೆಯಾಗಿರಿಸು, ಮುನ್ನಡೆಸು, ಕೈ ಹಿಡಿದು ನಾವಾಡೋ ಪದ ಪದದಲ್ಲೂ ಸಂಚರಿಸು, ಹೂವಲ್ಲಿ ಜೇನು ಗುಡಿ ಕಟ್ಟದೇನೋ, ನೀರಲ್ಲಿ ಮೀನು ಅಡಿ ಮುಟ್ಟದೇನೋ, ಆ ದೈವದಾಜ್ಞೆನೇ ಎಲ್ಲನೂ. Thank you.
Please be seated. Thank you, Nanika, for that soul-enriching song.
We now move to a sacred moment, the lighting of the lamp, symbolizing the dispelling of darkness and the enlightenment of knowledge.
I kindly request our dignitaries on stage to do the honors. And I also request Dr. Sridhar Reddy and Dr. Kiran Naidar to please join the lighting of the lamp. I request one participant to please join in the lighting of the lamp. Now to share insights into this grand conference, I invite Dr. Parmesh Chari BD, Conference Chair, NMITCON 2025, and Professor and Head of the Department of ECE, NMIT, and also Vice Chair, MDC IEEE Bangalore Section, to speak about IEEE NMITCON 2025.
Hello, Namaskara. Very good morning, Honorable present here. Respected dignitaries on the dais, esteemed guests, IEEE members, ladies and gentlemen, my fellow participants. It is with immense pleasure and honor that I welcome you all to the third IEEE International Conference on Networks, Multimedia and Information Technology, NMITCON 2025, organized by Nitte Institute of Technology in association with IEEE Bangalore section. At the outset, I would like to express our deep reverence and heartfelt gratitude to the visionary founders of the Nitte Education Trust, Justice K.S. Hegde and Srimati Meenakshi Hegde. Their foresight and dedication continue to guide us as we carry forward their remarkable legacy through academic and research excellence. We seek their blessings as we host yet another edition of this prestigious conference. I would also like to express our gratitude to Dr. Vinay Hegde, Honorable Chancellor of Nitte Deemed to be University, whose leadership and unwavering support have been a source of constant inspiration. It is our privilege to extend a warm welcome to our esteemed international guests, Professor Zuan from Spain, Professor Supavati from Thailand. We extend our sincere gratitude to each of you for graciously accepting our invitation and being part of this significant occasion. Your presence and insights will undoubtedly inspire and enrich the experience of participants at NMITCON 2025. Before proceeding further, we know that IEEE is the world's largest professional organization of technical profession with more than 450,000 members across 160 countries around the world. Association with the technical professional body will help in receiving recognition by accreditation bodies like NBA and the NET. In IEEE, there are 39 technical societies representing the wide range of IEEE technical interest. Also, IEEE is not limited only to computer science and electronics engineering. All branch of engineering and even management people can also join IEEE and can start various society chapters under IEEE. Our IEEE student branch of NMIT is proud to recognize as one of the most vibrant and active student branches under IEEE Bangalore section, currently comprising around 200 enthusiastic members. The IEEE student branch of NMIT continues to flourish and achieving significant milestones and recognition at both regional and national levels. Our IEEE Bangalore our student branch has received Outstanding Student Branch Award from IEEE Bangalore section in 2023, and also IEEE Student Branch Outstanding Student Branch Award from IEEE India Council in 2020-24. And our IEEE Student Branch, IEEE ASS Student Branch chapter received an 75,000 grant from IEEE ASS under prestigious DSTI initiative. These accomplishments reflect the dedication of our student members and strength of our leadership and our commitment to fostering innovation, collaboration, and technical excellence within the IEEE community. The NMITCON conference series has steadily established itself as a prestigious global platform for research, innovation in networks, multimedia, and information technology. NMITCON 2023, held in 1st and 2nd September 2023, achieved remarkable global reach, receiving over 2,800 paper submissions across the world. We take pride in sharing the 285 high-quality papers were published in IEEE Explore on 17th October 2023 and have since been indexed in Scopus, making significant milestone in our academic journey. NMITCON 2024, held in 9th and 10th August 2024, continued this upward trajectory with 2,666 paper submissions. Once again, the conference stood out on global stage. Around 289 selected papers were published in IEEE Explore on 4th October 2024, also indexed in Scopus, reflecting the consistent quality and impact of the event. Now, the NMITCON 2024 has a set of new benchmark in participation and academic excellence. The conference has attracted staggering 4,260 paper submissions, including international contributions, and witnessed the enthusiastic participation from across India, especially in the state of Karnataka. Given the overwhelming responses, the selection process is highly competitive. Around 290 papers were accepted for presentation, bringing the acceptance rate below 10%, aligning the high standards expected of IEEE conferences. A total of 28 technical sessions, both offline and online, are scheduled. Today, we have 16 offline sessions, and each session chaired by distinguished experts from academia and industry, both national and international. These sessions promise foster insightful discussions, valuable feedback, and knowledge exchange at a global level. As we reflect on the accomplishment of this conference, we must also recognize the collaborative spirit that made it possible. Behind the exchange of knowledge of NMITCON 2025 has fostered meaningful global partnership and inspired future innovation. I take this opportunity to express sincere appreciation to the management of Nitte Meenakshi, Minister of Technology, especially Dr. Sandeep Shastri, Vice President, Nitte University Campus, Bengaluru, and Mr. Rohit Punjam, Administrator, Nitte Education Trust, and Principal Dr. H.C. Nagaraj, Principal, for their unwavering encouragement and supporting to IEEE initiatives. My heartfelt thanks to all the contributors, participants, sponsors, and partners for making this conference a grand success. As we move forward, let us carry out the spirit of collaboration, innovation, and continuous learning that this platform stands for. Together, we can drive impactful change in the dynamic world of networks, multimedia, and information technology. Thank you once again for being part of NMITCON 2025. Let's make the event memorable and meaningful for all. Thank you.
Thank you, sir, for helping us to understand the impact IEEE has towards scholarly efforts. And thank you, sir, for your vision and leadership in spearheading this event.
It's now time for a significant milestone, the NMITCON 2025 proceedings. I now invite our dignitaries to unveil this symbol of scholarly effort and achievement.
Sir, come close.
Thank you for unveiling the fruit of rigorous academic pursuit.
I now request the dignitaries on the stage to please be seated in the front rows.
Yeah.
Professor Juan Manuel Corcado, Rector of the University of Salamanca, Spain, has graciously traveled from Spain to NMIT for the second time. He has also been a strong supporter of this initiative, and he has also served as the president of the IEEE Systems, Man and Cybernetic Society. I now invite Professor Corcado to deliver the inaugural and keynote address.
Namaskara, Bengaluru. Querida, it is for me an honor to be here for this opening ceremony and to deliver this keynote speech. But before that, I would like to thank the organizing committee for the effort they have done to organize this conference, and also for inviting me to this beautiful university, and for also inviting me to this amazing city. The third IEEE conference, international conference on network, multimedia, and information technology, holds here at the Nitte Institute of Technology in Bengaluru. Is an international event that has attracted the attention of many people, many students, many postdocs, and the international community, and that's why it's an honor for the University of Salamanca to stand as one academic partner of this NMITCON 2025. So before going into the talk, I would like to also to thank Mr. Rohin Puja, administrator. Thank you very much for all your work. Also to Shandep Shanti, Vice President of the university, to H.C. Nagarak, Principal also of the university. Thank you very much. To Shaden Reddy, Director of Curriculum Development of the Nitte University Campus. Dr. Kinar Aita, Director of the Research, Development and Accreditation, and also my friend and colleague, Dr. Paramishan Chari, Professor and Head of the ECE at this university. So thank you very much. So today we are going to talk a little bit about generative AI. We all know what it is, I know that we have heard about ChatGPT, DeepSeek, all of this, but not everybody knows how these large language models work and are trained. So what we will see today in these few minutes is how we can interrogate the system and how the system works from behind. So when you use them, you know how they have been trained and also what they can do for you and their peculiarities. So you probably have been using large language model, but you don't know that the networks behind there are so simple as this one. This is how, for example, ChatGPT started to become a reality, and this is the pseudocode you can use. And then a few years later, we had ChatGPT, and everything is very recent. And the difference between one and another is not that big. What is behind all of these algorithms is that we have a huge computing power behind these algorithms that are able to understand, to be trained with a huge amount of data as never before happened in our reality. So, for example, we have now the algorithms that are able to deal with data from different sources, with different structure. So this is what this is making the difference. We are using now multimodal learning. What does that mean? Before, in the old times, but the old times is a decade ago, a few years back, we were able to identify a problem, use one set of data or information, and use a network or an expert system, whether we could use connectionist model or symbolic models to deal with this particular type of data to try to solve a problem. But it was just one type of data and one algorithm. And you see, problems are more complicated than that. When we are facing a problem, sometimes we have data, sometimes we have information, probably we have both type of things, and sometimes information comes from different sources: images, sound, smells, signals, everything. So now with this new AI, we are able, with algorithms such as this one, able to deal with this type of product. So we will see how also we can not just get a solution, but get an explanation of how this solution is obtained with the data we have. So basically, I just took a picture a few days ago on a road, you see, in the past, if I wanted to understand what was behind that picture, well, I had to create a specific model that were able to understand the concept and understand the data, and it was hard work. Now we have a large language model. We can interrogate, because it's not an algorithm itself, it's a communication model, which I will explain you why. But now with these models, what can we do? We can ask them what it is there, and the model say, okay, because they can understand signals, they can understand letters, they can understand sentences, they can read a plate of a car, they can identify a car, they can identify a road, they can identify a tree, they can identify houses and everything. And we haven't trained ChatGPT to solve this particular problem. And after that, we can ask them, I have the symptoms, which type of disease do you think I have? Or I can give them a mathematical problem and ask ChatGPT the solution, and may find a right solution for that. So it's a very, very open structure. But now the beauty of this is that we can say how did you conclusion come about? How did you find that there was a car there was a road and everything? So with ChatGPT, or with DeepSeek, or with Perplexity, or with any other of the large language model we have around, we can do that. And the point of that is we can personalize this system to our needs. For example, we can create a product now that is specific to solve a particular problem, not just a general model, okay? Because when we train this large language model, we use a lot of information, but not everything. So if we ask a large language model, how many people is in this conference at this point of time, they will know. They will not know that information. But if we create a specific and a specific tool that use this large language model to know what are these type of conferences, what is what has happened before and what is going on with the NMITCON 2024, 2025, and so on. Probably this system will inform us about how many people is here, what type of students are here, what type of scientific interest have the people attending the conference, and so on, because we have trained the system and will not hallucinate, will just provide us the right information. And this is thanks to this new approach, the RAGs. RAGs are very impressive retrieval augmented generation models that are built on this large language model. So let's see how we can build this RAG system that are a special system that tell us a lot about a problem. So for example, we have a medical guide about colon cancer. We put all the medical guides about colon cancer, all the information we have in a hospital about colon cancer. And we can create an expert system based on that information. And we can tell ChatGPT of this sick or perplexity, just answer to my question based on this information about the problem. Don't hallucinate with other information you have behind it. So we can have a real expert system that gives us the right solution. Let's see how we can build all of that. And it's very simple. What we have is the large language model here behind the large language model, and then we have a database which are used to retrain this large language model, and we can say, okay, this is what you need to use to answer my question. Don't use anything else. The large language model is a communication system that understands our language and then will answer our question. So this large language model, to understand really how they work, we need to see how we train the system. Okay, it's important for us to know that we are using huge networks, not as this one, but even bigger or even bigger than that. So you should understand that, for example, to build ChatGPT, they use 175 billion parameters. You know what is a parameter, because we all hear about parameters. A parameter is just the value of one of these communications between two cells of the network. So you can imagine how big this network is. So we have so many millions of parameters that when we present them on a, for example, two-dimensional space, is a map of points, which we call the latency space. This is the real brain of our large language model, which make us understand. This is a neuron we use an input, we get an output out of them, and what we are doing by training the network with a vectorial computer. So nowadays we don't train, when we train a network like that, we use tokens, basically parts of paragraph of books, paragraph of things, and I will show you how we transform these paragraphs or these words in something that a network can understand. But what we try to do is to associate an input to an output by modifying the weights, by modify the latency space and adapt to the knowledge. So at the end of the day, what we do with our RAG system is to adapt all of this network just to the information we are really interested in, without losing the communication possibility with the system. So basically, what we have to do is to put all the information we have into a vector. Okay, we create a vector that will help us to represent those elements that have that we know. For example, all the words of our languages. But we can represent the sentences. But we can represent a whole book inside. We can represent everything of different levels in the same latency space. Let's see how we do that. Okay. For example, we know scientists have identified doing research in AI now it takes a lot of money. So there are some groups that told us that, for example, the vector to represent one word, what is a microphone, for example, what is a car, what is a pencil, what is a piece of paper, to represent all of this, we need between 768 characters or elements, variables like this, or 2040 or 48. Between these parameters, we can create a vector, and this is a vector only of 10 characteristics. And these are the words I will represent. Here, I will have all the words in one language. But you see, this is a sentence. I can represent a sentence. I say, okay, what is the value of this sentence with respect, for example, to navigation, to cargo handling, to emotion, if it's an animal or not, and so on. But here, I have selected only a few words. 1, 2, 3, 4, 5, 6, 7, 8. 8 words and 7 words in a sentence. So now a specialist on understanding the language has said, okay, attract. What attracts to see with navigation? Between 1 or minus 71. 1 has that something to see, or minus 1 is nothing to see. Okay, you see, so we find a vector for each word. Those words, for example, a truck and a ship, have a vector which is quite similar, which is much different to a pizza. Pizza is something much more different to a truck than a ship to a truck. Burger is similar maybe to its food also, has many things in much similarities. Train, this vector here is also similar to truck and ship. Apple is food, which is similar to pizza or in a way. A plane also. I am happy. This is different to the others. So we can represent all the concepts, all the sentences, all the words in a vector. Okay, those vectors are the ones we use to train the network. Okay, the large language model. It's important to know that. But you know why? Okay, you see, I have some words, but the same word, the same element is not the same in the same language for the same society. I'll give you an example. Okay, for you, for example, for you a cow. For some of you, a cow maybe a holy animal. For me, as a Spanish, a cow is one animal more, nothing special. Or people, for some people, don't eat pork, and for others, they eat pork. So the concept of the pork is different. So we can see it one animal or an animal as food also, okay? Or a holy animal and just an animal itself. So it's important to know that these vectors, depending on who is analyzing them, are different. That's why it's so important that you, in your country, with your language, with your society, build your own large language model. Now, most of the large language models are built by Chinese or by Americans. But so it's important for us in our culture, in Spanish, or in India and in other countries, to have our own large language model, because that will represent us and they will represent what we have. It's important also to know that, so when you are using and interrogating a large language model, you should know that they are biased by the people who have developed this large language model. Okay, so as just to finish, because we don't have a lot of time and we probably are out of the schedule. Whenever we have an input, so we should have that we have a large language model that can understand us, but we can create a product that can be specialized in something else. And this is very important. I am using that in my university. We got Notebook LM, which work on Gemini from Google, okay? It's a RAG model. So all our students can create her notes, her books. In each book, one per each subject. We can put all the notes of the professors. they can put all the information they can find on internet on that subject, and they can create and adapt their teaching material to their needs. So they can create their own exams to interrogate themselves how they are doing. They can progress when even when they are at home or at a library studying without the need of a professor there. That is reducing our workload. That is improving the ability of students to learn, because we can make sure, we are sure that they learn whatever they should learn, and also they can even improve the material with other material, and they can share among themselves the notes, which are good. They can share the exams, they can share the tests, and this is a big improvement, especially if you are doing a little bit online learning, because sometimes you don't have time, some people don't have time to come to the university very often, and this is a way to a method, a good method to have your own tutorial at home that help you to that development. So you have many RACs platform. Notebook LM is one, but there are others here, and I'm sure you will share. Will have access to this presentation. In case you want to create one of these and use one of these products here, which are open source and you can use in many cases. So in that sense, generative AI and RACs, they don't have common sense. Okay? We should understand that they are mathematical models, statistical models, that they give us an answer depending on the quality of the information we provide them. But you see, the beauty of them is that they have a common interrogation languages. It's a common language. They can understand our natural language processing, and they can understand many different languages, which is also very good. In that sense, we know that the common sense should be our common sense. So we need to know how to interrogate the system to extract the information, and also we should not be worried about the ability of the AI to maybe develop a model that can control our lives. This is not possible nowadays. We control the AI, and the AI do whatever we want to do. So, but be careful with all of that. So human common sense is important, because that will allow us to develop systems that in a way will be able to perform whatever we want whenever it's needed. If we want a car, the barrier of the car park to open after we pay the toll, we don't need any supervision of this AI. It's something we can know. It's simple, and it doesn't provide us a problem. But when we are in a clinical theater with a robot, a Da Vinci robot, we don't want to leave it alone just with ourselves. We want a professional to be there. So in that sense, RACs and large language models can facilitate the education, the transformation, and also at an engineering point of view. There are many engineering firms that now are working with computer scientists to develop the models. Probably it's not the best model, the final model they have for civil engineering, or for when you create a new structure for energy infrastructure or whatever. But you can, if you are a good engineer, with the help of a computer scientist that support you on the development of the systems, or yourself, because this is something that can be learned by anyone, you can progress much faster and be more efficient on your work. I was in a talk in a meeting with the president of the United Arab Emirates last year, and he told us, Mohammed bin Zayed, His Highness told us, the AI will not change. The AI will not take our work, but someone who knows AI, who know how to use these tools, will take our job. So I advise you, now that it's easy still, to be able to monitor how all of this technology is progressing, because when you finish the university, when you finish your studies, even if you are doing research as a PhD, if you make good use of these tools, you can be much better than others that they don't use, because you can be more efficient, faster, and have a tool that speed up your work significantly. So basically, one more thing, agents and multi-agent system in AI have been we have been working a lot. We have developed some tools with this technology. Very hard to develop technology with multi-agent systems, especially for the commercial world, because they are asking us for something fast and quick. And sometimes it's more complicated to build the multi-agent system than to solve the problems you are trying to solve with this technology. But now there is this new concept of agentic AI. I wanted just to present it for those who doesn't know, because agentic AI is basically to use an agent that have a large language model, a specialized large language model behind. With the RAG technology, you can build your own agents that are supporting your work and are even able to interact with different sources of information. So with this, I want to finish. Again, thank you to all of you for listening to me, and I am at your disposal if you need anything. Thank you very much for that.
Thank you, Professor, for that inspiring and visionary keynote address.
It is now our honor to invite our guiding force behind NMIT, our embedded and beloved principal, Dr. Hetzi Nagraj sir, to address this August gathering.
Good morning. Our esteemed chief guest and keynote speaker, Professor Juan Manuel, Rector, University of Salamanca, Spain. The guest of honor, Professor Dr. Supavadi Aramvit, Chair IEEE Thailand section. Our other professors from Mauritius, other chairpersons from various institutions of our country, the head of Department of Electronics Communication Engineering, Dr. Parameshwar Chari, my dear faculty members, dear student friends, dear participants, members from press and media, and also all other invitees. It is my pleasure to welcome all of you for this inaugural session of the third IEEE International Conference on Networks, Multimedia, and Information Technology, that is the NMIT, NMITCON. And also our NMIT is also our college, Nitte Meenakshi Institute of Technology. For this third series, we received about 4,260 papers. Out of these 4,260 papers, about 290 papers were selected for presentation. The review was done by various experts, professors from IEEE, then the Indian Institute of Science, then the Indian Institute of Information Technology, IIT Bangalore, like that, and all our other experts from various institutions in our country. So this conference is mainly intended to networking and collaboration. They are very, very important. So we can collaborate with other researchers. This is an international conference, so a lot of people from other countries also are here. So collaborate with them, network with them, learn things always. I used to say always, lifelong learning, LLL. Lifelong learning is very important, and we have to keep learning till we survive in this society. There is no substitute for knowledge. knowledge is power. So we have to gain knowledge. We have to move towards improvement day by day. There is no finishing line for improvement. So always we move towards improvement by gaining knowledge, which is very, very important in everyone's life. And our keynote speaker has given a detailed picture on the generative AI. It is very, very important, which is a tool for all walks of our life. And also he explained about architecture of RAG, that is a retrieval augmented generation, and also LLMs, that is large language models. They play a vital role in all walks of our life. And today there are two important things. One is, in our country, 30 years back, the mobile first was used in our country. That is, our cabinet minister, by name, he is a cabinet minister for telecom in our country at Delhi, by name Sukram. He made a first call using his mobile phone, Nokia phone, on this day to the then Chief Minister of West Bengal, Jyoti Basu. So this is a very significant day in our country. That is the start of Nokia mobile phone, that is mobile technology, about 30 years back. The second one is, today the World Wide Web, WWW, was also started, this one. And today, happy World Wide Web to all the members. It was invented by the Sir Timothy John, scientist. So today is the World WWW Day. So there are two significant days on this August 1st. I'm very happy that a lot of participants, lot of chairpersons and the guests, they have come based upon our invitation. So on behalf of the management, on behalf of the college, I thank all of them for their presence for this 2-day conference. That is today and tomorrow. And our commitment by your faculty members and our student friends is enormous. Last year, I can say that for the same inauguration, the head of department of our EC, Parmeshchari, who is the chairperson for this conference, was in hospital last year. In that situation, he came to college for this conference for half an hour, took permission from the doctor, medical doctor, he came and attended the inauguration, again went back to hospital last year. And I can say that this shows his commitment for it. And our chief guest today, the keynote speaker, Dr. Juan Manuel, he had come with his son last year, and he also went to hospital to see him. So I met him in the hospital also in addition to inaugural function. So this shows the relationship and also the support by the international delegates to our institute. And we also signed MOU with him, that is University of Salamanca, Spain, last year MOU for the teachers, the exchange, student exchange program, collaboration for research and all. We signed MOU with the So a lot of universities are helping us, and also every year we conduct 4 international conferences every year. This is as per the direction of our President Sri Vinay Hegde and our advisor Professor N.R. Shetty. N.R. Shetty was the former Vice Chancellor of Bangalore University for 2 terms. He was also the Chancellor of Central University of Karnataka, appointed by the President of India. So 4 conferences, one is this conference. In support of IEEE Bangalore section. Always very grateful to Bangalore, IEEE Bangalore section. They support us. This is a 3rd in series. So this NMITCON, that is supported by IEEE 1 conference. The other one is all IT branches together. IT branches together, another conference, SCCOM. Other one is non-IT, mechanical, civil and aeronautical. They conduct another conference, non-IT branches. And one more is the management studies, MBA department. They conduct 1 more conference. So every year we conduct 4 conferences in the college, which we made it mandatory. And we invite people, experts from various parts of our country and abroad, and to interact with our students. Our students also will get benefit of this. So with this, I once again welcome all of you, and also once again I thank all of you for your presence. I wish you all the best and have a comfortable stay for today and tomorrow in our campus. Thank you.
Thank you, sir, for your continuous encouragement and leadership.
We are delighted to welcome a leading name in multimedia analytics and video technology, Professor Supavadi Aramvit. She currently holds several prestigious leadership roles in IEEE, including Chair IEEE Thailand Section, Chair-elect IEEE New Initiative Committee, to name a few. We now request Professor Supavadi Aramvit to deliver her keynote address.
My third visit, and today with the NMITCON, yeah, I think that you will learn a lot, okay, about the field of the network, multimedia, and information technologies. Okay, yeah. So today I'm gonna talk about my research. Okay, as introduced, I do the research in the video technology. So when we talk about video technology, it has to come with the image first, right? And then also video carry a lot more data, right? So to analyze image, to analyze video, okay, today with the artificial intelligence, machine learning, and deep learning, yeah, we can do a lot more thing on the analytics side. Yeah, so today I would like to talk about like how, what is the recent video analytic trend, and then also show example of the research that we have done at the Chulalongkorn universities. Okay, so the field that I interest, okay, would be the video signal processing. So it is like the compression. So today we all know that because video data has been a tremendous amount, right? So to be able to compress is very important. So compress is already mandatory. All of the information that we carry over the mobile internet. We have the Zoom meeting, we have the all of the live video call, we have digital television, right? So all of the things need the compression. So my PhD I did on the wireless video transmission, and at that time, okay, is only second generation mobile system. Like today we are fifth generation, and we are moved to sixth generation. Right, so you can imagine the bandwidth that we have at that time, and then the technology of the mobile phone that we have at that time, right? So it is only second generation, we can only send SMS, but that is the first time that they think about the video technology standard, video compression standard. Okay, that is like the foundation for today. And then when I become the staff at the Chulalongkorn University, I also explore the video analytics because mainly it has a lot of the application. So I would like to show you the evolution, right? Because we all start about the deep learning, everything today, but what about like 50 years ago, right? When you have the analog image and video, right? And at the transition point, they become the digital. When all of the media become the digital, right? We can do a lot of things. We can manipulate it, right? We can extract the pixel, we can extract the feature, right? And we can learn a lot, right? So if we talk about like the early system, right? Everything is about the rule base. Rule base is mean that it's like an if and then, right? So you need to set the condition, right? But it is impossible for you to do the rule base. Okay, for every kind of the scenario, right? So, and then in the rule base, then we have the early computer vision, right? Computer vision is the field that mainly you get the image from the camera, right? And then you would try to analyze it, yeah. So this show example of the research that I first did at the Chulalongkorn University in 2006. Right, so it is about like almost 20 years ago, right? So at that time, if I work about the problem of the analyzing the content from CCTV camera, right? So mainly it's about you need to know a person, right? You need to be able to detect person and track, right? Their walking or their whereabouts, right? may need to count the number of the person in the scene. That may be useful, right? And then you can extract, okay, all of the features, right? What would be the feature? We need to know like the skin color, the clothing color, is wearing hood or not, wearing sun, or estimate the height, right? Or is holding a bag or not, right? Because all of these feature is very important for you, right? If you want to do some suspicious analysis later on, right? And then there are like the face recognition. I call this face cataloging, right? Because face recognition, it has two types. Okay, one is a single shot face recognition in which it apply in like in immigration, in the bank where you have to authenticate yourself, right? So for that, the accuracy of the system is already like almost 100%, right? But there are the case of the real-time face recognition which still is challenging because you're not in front of the camera, right? The camera may spot you when you walk very far. So it means that the camera can get like part of your face and maybe only small face. Okay, and you not like turn directly to the camera. Okay, so that is something that's challenging. So at that time, we also do the prototype to develop what we call the face cataloging system. Okay, so mainly if the person come into the scene, you just crop the face. Okay, so it may not be perfect, but somehow later, okay, you can learn. Okay, and then you may be able to detect the people again. Okay, when they come into the scene. Right? And then the super resolution. What is the super resolution? Right, we have the image, you will have the resolution. Okay, and now what we call the you can think of the camera, right? iPhone camera or digital camera, how many megapixel? That is the resolution, right? So typically we would like to have the image at highest resolution as possible. But of course, if you have at the highest resolution, right, it's gonna consume more space. Okay, but at high resolution, it comes with a lot of detail, and then you can extract the feature, so you can do recognition easier. Okay, but the actual situation is it may not be like that because many times you stay far from the camera, the lighting is very dim. Okay, so in many cases, it raises a lot of problem in doing the face recognition, license plate recognition. That is for example. Okay, and then there are some kind of the monitoring and warning, right? So this would be something that if you can extract the feature, now you have to compose all the necessary feature together and then apply into the several of the scenario. Okay, so at that time we can do something basic like the zone alarm. Like if you highlight the scene and people come into the scene for specific of time or of number of frame, you may alarm. Or if the person come into the forbidden direction, okay, you can also alarm, right? And there are many ways that you can set up, like hand over the object if the person walk or run too fast, right? But technology at that time does not allow you to do much because you deal with the pixel, right? So I mean it is very, very difficult. Okay. And this is another work that we have done, and I would say that this type of work is still very challenging today. It's hard to see the actual system. Okay, it is what we call the person tracking to multiple cooperative camera. So you can imagine that you have like 100 camera in the building. Okay, and then like if the person come into the reception and then they take the face, right? Then when the people come to the different floor, that camera on the other floor should be able to detect and recognize that person. Okay, so this is how, because the camera connect with the IP network, right? So somehow the information can send, right? But the problem, okay, is that the camera may not be able to detect because the environment in the third floor or the fifth floor would be different. So when you extract the feature, it's not the same, especially if you use a color feature. Okay, so this would be something that quite challenging from that time still today. Okay, and then on the scene, right? It's the first time, right, that we have first paper on the deep learning, especially on the convolutional neural network or CNN. And we know that CNN has been used a lot for the image and then video. Okay. So here we show the AI-based video anomaly detection where we use the generative adversarial network or GAN, okay, as the center point, okay, of the algorithm. Okay. So mainly you can see that the highlight, right? The highlight color is the one that is called anomaly. Okay. So I would like to talk about anomaly, right? So anomaly defined as something that is deviated from something that is normal. Okay, so it means anomaly can be different in many contexts. It depends on how you define it. Okay, that actually when the definition is like this, right, it makes the research problem quite more difficult, right? Because when we say anomaly, okay, so anomaly in what kind of scene, right? For example, if I ask you now, do you think what is the anomaly in this room? Can you tell me what is the anomaly in this room now? You think you are anomaly? So when we define, we have to set the standard for like what is now the standard action of people in this room? Sit, right? So if you are sitting, you are not anomaly, right? But if you somehow stand, which is like a minority, right? And if I stand in front of microphone, maybe I'm the most anomaly in this room. Okay, so that is like the example how we define anomaly. Okay, so anomaly detection, right? In this case, it means that it will learn, right, that the normal walking speed is the normal, and then if people fled the scene, okay, it may alarm something. Okay, and that if you detect some situation like that, it should be alarmed and sent to the police or the officer as soon as possible. Okay, so sometimes real-time video analytics, okay, is mostly important in many cases. Okay. And these are some other example, right? You can detect when the people fall, okay, or I'm not sure I can, okay. Okay, and then like some thief come into the store or people are fighting, right? It is something that we can do on the anomaly detection. And then we also apply, right? Because maybe when you do research, you will test your algorithm on the public data set, right? But this one, we put it, the video feed is directly from the CCTV camera. Okay, and then the system will start to learn, okay, that if the action is normal or when that it will calculate the anomaly score down there. Okay, so we can see that now the people falling down, okay, anomaly score is very high, and then we can start capturing those scenes. So you can see that there are many important applications on this. Right, you can like the elderly people at home, okay, or many other, okay. So that is something that we did on the anomaly detection, okay. That you could apply it, okay, not just only on the research paper. So we can see that, right, today if you want to work on video classification, detection, recognition, okay, mainly you're gonna have to use the CNN, and CNN has so many architecture, right? So if you work on this area, you need to keep up to date, right? Because now all of the algorithm people will put it on the GitHub, right? And if you are interested in this state of the art model, right, you can download the code from the GitHub, right? And then mainly you may do some improvement. Because if you do some improvement to the current architecture, right, or current proposed method, that is your contribution, right? But if people can do that now, it means that now for the deep learning model, nothing is come from the scratch, right? It's like built on top of another. So my advice is that you need to work very fast. You need to keep looking, update your research, okay, to be the present. So what would be the key trend that keep the future in this area, right? First, I already talked about that speed is very important. Okay, so real-time analytics. Okay, you need to send out the alarm as soon as possible. Okay, so even you use the algorithm on the cloud, or mainly you may need to do it, okay, on the hardware like the FPGA. Okay, that's come to the important part. The second one would be the edge computing, right? So usually when we talk about the cloud, it's mean that if you have camera at one place, you need to send all the video, okay, to the central server and process that, right? That would take time and take the bandwidth, right? So today the concept of the edge computing, or they call it edge AI, is that there is the new system on chip FPGA that have the deep learning processing unit on it, okay? And then you can place that close to the source or the camera. Or even you have the AI camera now, it means you have the edge AI inside there. So for that, it means that you can make decision, okay, quickly. Okay, does not need to send video, okay, to the central server. And then the multimodal analysis, right? So video is one modality, image is one modality, right? But how about audio and other kind of information that come from other sensor? So it is really important that you can fuse it together, right? So for example, the situation like argument or fighting, right? If you also consider audio, right, you can detect the abnormality faster, okay? And then the explainable AI browser one already talked about it, right? So now we have the model AI make all the decision, right? So how can we know that that decision, right, is trustable, okay, and like fair, okay? So explainable AI is also very important. And one thing that I didn't put here but it's important as well is in terms of the privacy, okay? Because now we are deal with, okay, the video and image, which is from the public camera, okay? So I would like to also show some of the work. So this is the board that I talk about. Okay, so this is the edge AI FPGA board, okay, of the Xilinx. Okay, so you can see that it has the DPU is a deep learning processing unit. Okay, and then like we implement some algorithm. So this is the super resolution algorithm. Okay, we would like to upscale resolution by 2 times, 3 times, and 4 times. And we can do it in real time. So you can see the frame rate. Okay. 25 frames per second. Okay, if you scale up more, okay, it will take more time. Okay, because mainly the complexity is more, the computational power you need is more. Okay, so this is one of the example of the super resolution for image clarity and enhancement. And this I also show you if you don't get the idea what would be the outcome, okay, of the image super resolution, right? So here you can see we have several work on this area. So this area we already have 12 journal and 16 conference paper and over 200 citations. Okay, so our research we focus on like general image, and we extend to the medical image. Okay, and on the face super resolution remote sensing has been the application because now the camera is from the satellite, right? So it is very far. Okay, so many times we would like to identify something. And also transformer based, which is like the current architecture, okay, of the deep learning. Okay. So here you can see that this is the low resolution. Okay. I mean, here I show it look like you have the same resolution, but actually the resolution is bigger. Okay. So here you can see that from you seeing nothing, right? So now you can see the eye. Here, low resolution, you cannot see the face at all. Okay, but with super resolution, right, we can upscale the resolution. And here you cannot find 2002. And then here we have the output. Okay. And this is the very important area in the medical imaging. Okay, on the endoscopic camera that go into your body. Okay, when doctor has to do the surgery, okay, they have to see clear image, okay, in order to make some decision. So here you can see that from seeing nothing, right? So here we see it very clear. So that the outcome of one of our other works. Okay, this also show that we also implement, okay, the CNN layer, okay, and then also do it as the video real time to detect the license plate, okay, with only this board and camera. Okay, so we can do it in real time, and this also we can do also the detection, okay, of the license plate clearer. Okay, the accuracy is very good. Okay. So coming toward the end of my talk, right? So what would be the application of the video analytics? And I think you can see from my example, right? So here we can see that it mainly in the smart city, right? Smart city of the CCTV camera or the traffic, right? That you need to monitor the car, okay? And then the healthcare that I show you the example in the medical diagnostic, okay? In the retail, okay, I think now when you go into the shopping mall, all of the shop has a camera, okay? If we want to do something, maybe they can track, right? You are interested in which kind of product, or they can count how many people in the store and what the statistic of people looking at the particular product. Okay. Manufacturing is important, right? If you want to mainly detect the defect, okay, of some kind of the metal or any kind of the product, right? And entertainment, okay, entertainment has also many in kind of the special effect and so on. So the future is intelligent vision. Okay, so I would say that the research in this area is very promising, and there's still a lot of the problem to be solved, right? And I already mentioned the key trend, right? The key trend, which is the real-time analytic, okay? The edge AI, multimodal analysis, and explainable AI, but still the privacy is very important. Okay, so I would like to conclude the talk, okay, that the future vision, okay, also now lie in the technology of the artificial intelligence and deep learning, right? And we can mainly solve the problem for the better of the community. Yeah, so thank you so much for your kind attention. You can send me email if you have the question. Yeah, thank you.
Thank you, Professor, for such an insightful and globally relevant talk. Now we have a video message played by Dr. David Camacho.
Hello, everyone, and welcome to this new edition of NMITCON conference. Nitte Meenakshi Institute of Technology at Bengaluru is organizing the third international conference in NMITCON 2025, and I'm really honored to serve as the general chair of this conference. The event's emphasis on practical applications rather than purely theoretical contributions is very well aligned with the evolving needs of today's corporate and industrial sectors. I'm delighted to share my message on this occasion. It was an honor to serve as the chief guest editor and keynote speaker at the first IEEE International Conference on Networks, Multimedia, and Information Technology in 2023. And I'm pleased to know that the accepted papers from the previous editions of NMITCON have been successfully published by IEEE, Explore, and Indexing in Scopus. The IEEE student branch at Nitte Meenakshi Institute of Technology has consistently demonstrated a strong commitment to organizing impactful student and professional activities. I could also like to commend the branch of its remarkable achievement in securing about 75,000 United States dollars grant from IEEE AESS for an innovative drone design project. I extend my most sincere congratulations to the organizing team led by Dr. Paramisari, along with the dedicated faculty and enthusiastic students of Nitte Institute of Technology, Bengaluru. Your collective efforts and active participation play a vital role in the continued success of conferences like NMITCON. Congratulations and my best wishes to have a successful event to the organization from Madrid. My best wishes again, and I wish you a
Thank you. To officially conclude this memorable event, I now request Dr. Sunil S., Associate Professor, Department of ECE, NMIT, to propose the vote of thanks.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. A very good morning to everyone present here. It is great honor to deliver the vote of thanks on behalf of the entire organizing committee of 3rd International Conference on Networks, Multimedia and Information Technology, NMITCON 2025, hosted by Nitte Meenakshi Institute of Technology in association with IEEE Bangalore section. We are deeply grateful to our chief guest, Professor Dr. John Corchado, and guest of honor, Professor Dr. Supavadi Aramvit, for gracing this event with their inspiring presence. Thank you, sir. Thank you, madam. Our sincere thanks also goes to the Bangalore IEEE section for their continued collaboration and support. In his absentia, we extend heartfelt gratitude to Professor N.R. Shetty, Senior Advisor, Nitte Education Trust, for his ongoing guidance. We express our sincere thanks to Sri Vinayagade, Chancellor, Nitte Deemed to be University, and Dr. Sandeep Shastri, Vice President, Nitte Deemed to be University, for their valuable support and guidance. We extend our heartfelt thanks to Mr. Rohit Punja, Administrator, and Dr. S.C. Nagaraj, Principal, NMIT, for their continuous encouragement. Thank you, sir. Special thanks to Dr. Sudhir Reddy J, Director, Curriculum Development, Dr. Kiran Aital, Director, R&D and Accreditation, Dr. Ita Shetty, Dean, Students Welfare, and especially Dr. Paramesh Acharya BD, Conference Chair, along with the team of ECE, AIML and AIDS teams, for their leadership and efforts. Thank you, sir. We also thank all the various heads of the departments, session chairs, reviewers, faculty coordinators, student volunteers, technical and administrative teams for their dedication and behind the scenes work. Thank you all. We sincerely thank all our participants, presenters, attendees from various around the world of your interest and contributions that made this conference more meaningful. Finally, our sincere appreciation goes to our sponsors, Simulations Labs Private Limited, University of Salamanca, Spain, University Technology Mauritius, collaborators and media partners for their generous support. As we conclude, let us carry forward the spirit of innovations and collaborations that NMITCON 2025 represents. Thank you once again and best wishes to all. Thank you.
And now request the audience to please rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे, तव शुभ आशीष मांगे, गाहे तव जय गाथा। जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे।
Kindly request you, please be seated. Audience, please be seated in your place. We have certain instructions to give to you before you leave. We will now have a group photo with the plenary speakers, please.
Come. We request plenary speaker.
We request all the plenary